Question number 1. So let us assume root 2 is rational. If it is rational, we can express in terms of p by q. So then root 2 is equal to p by q, where p and q are integers and co-primes. Next, observe this given data and squaring on both sides. Squaring on both sides. Squaring on both sides, then it will becomes root 2 whole square is equal to p by q whole square, and square root 2 cancel. 2 is equal to p square by q square. Now cross multiply it. 2q square is equal to p square. From this statement we can conclude one thing. 2 divides p square as well p also. Can I conclude that 2 is a factor of p square and p? Then 2 is factor for p. So make it as equation number 1. The factor for p. Now I'll consider that. So then 2 equal to 2 times of a. And this is Roman number 1 we consider. And take then replace in this equation. So Roman number 1 equation implies 2q square is equal to p square, and replace p value in it. 2q square is equal to 2a whole square, and 2q square is equal to 4a square. Now this 2 table in 4 2 times cancel, and we can say that q square is equal to 2a square. The same it is came reverse. Observe this statement and this statement looking similar but in terms of q. So now I will conclude the same condition. 2 divides q square as well q also. If it is dividing, I can say that 2 is factor for q, and I'll make it is equation number 2. Observe equation number 1. 2 is a factor for p and 2 is a factor for q also. So we can conclude that. Now I can conclude that from equation 1 and 2, 2 is common factor for p and q. But actually what is our consideration? P and q are co-primes. But now I am proving what? Both they having common factor as 2. It means that our assumption is wrong, definitely. So it is contradict the fact. So our assumption is wrong. It contradict the fact. Contradict the fact. Root 2 is irrational. So we can conclude that therefore root 2 is irrational. I hope you understand.